So in this one, we're going to talk about analog digital circuits. I'll mention memory, but they took it off the exam. I/O devices also took off the exam. Microwave ICs, display devices, connectors, and ferrite cores. So what is an analog integrated circuit? It's a linear integrated circuit or analog chip on a single piece of semiconductor material. Can have one or more analog circuits on it. Typically, it's going to be a voltage regulator, an operational amplifier, wideband RF amplifiers, find on high frequency stuff, or it can be filters, low pass, high pass, band pass filters, all in one integrated circuit. Would have to be relatively high frequencies. We would have enough inductance capacitance. So what kind of device is an integrated circuit operational amplifier? Anna? Here. So what's a digital integrated circuit? It's a single piece of semiconductor material, usually a large number of logic gates on it. Could be a microprocessor, a lot of bigger gates, counters, all sorts of things. Typically, and I guess TTL is kind of phasing out, but it's still around. There was a thing called RTL in the beginning, resistor transistor logic. That got replaced with transistor logic. And it gave you relatively high speeds, but it was high power consumption. So when you got to doing portable devices like cell phones and things like that, then they started going to CMOS circuitry, complementary metal oxide semiconductors. It has much lower power, and they can operate at lower voltages. TTL is typically 5-volt range. So which of the following is an advantage of CMOS compared to TTL? Low power. Low power. So a memory integrated circuit used to be in there. You needed to know what RAM was, random access memory, which is volatile, or read-only memory, which is non-volatile.
They took that out. What did they put in?
Nothing. They dropped it.
They figured
You
everybody
don't need to know it.
Computers are just,
Well, no.
it's not worth asking anymore.
Yeah, I get it. I guess they assume everybody knows it.
Everybody knows the RAM.
Okay, so what's monolithic microwave integrated circuit, or an MMIC? It's a circuit for doing stuff at microwave frequencies in the 300, although I thought it was probably more like 3 gigahertz, but anyway, they say 300 to 300 gigahertz. And it's a single device that will have almost like a radio on it. And they're typically designed so that they have 50 ohm input-output impedance, so that you can easily connect them together circuits. You connect them up with SMA connectors. The other thing you need to remember is MMIC and what it stands for. Like there. So what is meant by the term MMIC?
Bravo.
Bravo. not sure why they bothered to ask that question.
Bill. They left the other one out.
So what is a display device? It's an electronic device whose purpose is to display information. It can be an LED that lights up, or it can be a numerical LED readout that shows a number. Liquid crystal displays show numbers as a result of a field effect, like a field effect transistor, but they require a light source, either a backlight like you have on your laptop, or ambient light where they've got a reflective background in order to see them. The light emitting diode is just a diode that happens to emit light of a specific color when it's forward biased. Now, you know, we talked about germanium and silicon have different threshold voltages. Light emitting diodes, basically every color has a different threshold voltage, and they're typically much higher. Can be up volt and a half. Something. It turns out that all diodes actually can emit light, but they don't emit very much light. So that's how they determined that characteristic, and now they can control the color and the amount of light by the type of material they use and get much more light out, much more efficiency.
Is it all in the visible spectrum? Is there some elsewhere?
It's infrared. And then there's blue light laser diodes, which will cut metal. Basically, for the light emitting diode, you need to know that it emits light when it's forward biased, and that liquid crystals require ambient or backlight to see. So how is an LED biased with emitting light? Delta. There's no tunnel effect, and we're not. Zener voltage range would be when you reverse polarity, forward bias. Connectors. What is an electrical connector? Get this big long definition. Making electrical connection between parts in a circuit.
That's right.
But
Does that need to be gender neutral?
Yeah, it's got female and male.
Man, they're going to have us call it X and XY.
you know, I just had to do a background investigation that SF 82, 85, whatever it was.
85.
And there's a question on there how I identify. Yeah.
Did you have to answer it?
I did. I said I was born male in 1944, and I still am.
Oh, now I don't ladies' room and now change right. Put her phone number.
And they haven't approved it yet, so I probably should. Okay, so before all this stuff, we used to call male connectors plugs and female connectors sockets for obvious sexist reasons. Connections can be movable or they could be permanent. You could have a crimped, like a butt connector connecting two wires together, and it doesn't disconnect. It's a permanent connection. In most cases, it requires some sort of tool, either some sort like a crimping connector or soldering iron if you're actually soldering the connections together. So we have basically low frequency type connectors used in audio or DC. And normally that's like a RCA phono connector. A lot of times now you'll see the little miniature phone plugs also, besides the RCA. They didn't put that on the exam, but I think those are more common now than RCA phono jacks. In the VHF range, normally you're going to see a PL259, which is the male plug PL, or an SO239, which is the socket female part of the connector. And they operate up to around 300 megahertz. Now, a lot of times you see them called UHF connectors. They're not. It's a VHF and below. In the UHF range, you're going to be using an N-type connector, an SMA type connector, BNC type connector. Those are all good up into the gigahertz. The N-type, I need to change that. They call them moisture resistant RF connectors, useful to 10 gigahertz. I'm not exactly sure what makes it moisture resistant, but that's what they claim. I don't see any kind of seal in there, but they do mate differently than a the PL259.
What, they aren't male and female anymore?
No, the end connectors are, but
Yeah.
I don't know what seals them.
I think maybe some of them made during the day.
Every cell phone antenna is type N. On towers.
Oh, yeah? Oh. Well, I mean, that's, if you're gonna operate UHF, probably want to type in connect.
And I had to laugh because the number of times you look at it at first glance, you think it's a 259.
Yeah,
Then you got to
they're
do it
about
all,
the same size.
Yeah. but they won't go together.
But they cost 3 times as much.
Yeah.
Unless you buy them from Times Microwave, and then they're more.
And then they're twice as difficult to solder correctly.
Well, some of them you don't have to solder.
Yeah.
If you use the like LMR 400 with solid center conductor, the way you strip it back is the center conductor actually goes into some little beryllium fingers.
Yep.
You don't have to crimp it or solder it. You just have to crimp the ferrule on the outside. So they're easier to put on.
And I'm going to make a plug for ADR cluster.
Okay. Good stuff.
And you can fully customize your cable. And they'll do all the way down, I believe it's RG70 to LMR 600. And so whatever connector in you need.
And now I just got to think you can get them with color-coded sheath on it.
Yep, and your call sign. Or some other, just like
Then you have SMA, which is a very small threaded connector. Actually, if you've got a handy-talkie, you've got a SMA connector for your antenna. And depending on whether it's Chinese or not, it might be a reverse SMA connector. They tend to make it difficult. Here's a picture, not to scale, of all the different connectors, because it looks like a BNC is the largest one.
Yeah.
And it's not.
MC.
Down at the bottom is their, which they call a UHF, but that's the PL259, which you see is only good for a little over 300 megahertz, 300, 400, something like that. It turns out the SMA is good for almost 18 gigahertz. And you find those a lot in side of high frequency equipment to connect stuff together internally. There's an N connector, can't see too well, but the center conductor is circular instead of a pin. So they made it a little bit different. I'm not familiar with the TNC. Looks like it's got some sort of insulator in there.
TNC, if I remember right, is like an N, but will handle about 4 times as much power.
Okay. Then you have this little MCX one. I don't know if you've ever seen it. If you've looked inside of something like a cell phone, a laptop, those are typically how they connect an antenna up to the circuit. It's a little snap-on connector. They're much, much smaller than that picture.
I'm trying to figure out what my niece is. And I think it's MCX. Because I want to warn her if I drop the roof.
Okay.
I only have to do it once.
There's your typical BNC, which most test equipment, unless it's really specialized or high frequency stuff, uses BNC connectors. Oscilloscope, signal generators, all those kinds of things are typically BNC connectors. Those are very easy to use. You know, it's a quick disconnect. It's just a twist and it locks.
And everything in an airplane is BNC.
They're good to 4 gigahertz. Test question. I don't know anything about an SMB or a mini UHF. It's not on the exam. I don't care.
There are many great online your first one. For the years.
Okay. So what's a typical upper frequency limit for a low SWR operation of a 50 ohm, which they are, BNC connectors?
4 gigahertz. Or
4 gigahertz. Which of the following describes a type N connector? Useful to 10 gigahertz. There's a little better picture there. You can see the center thing somewhat. I guess I'm going to have to investigate why they claim they're moisture resistant. What is an SMA connector?
A
Threaded connector suitable for signals, they say up to several gigahertz, actually, it's the highest frequency in the bunch. Okay, which of these connector types is commonly used for low frequency or DC signal connections to a transceiver?
It's
259.
You know, 259? Low frequency or DC signals.
Oh,
Think audio.
oh,
C.
C.
Charlie.
Got to read the whole damn question.
Yeah.
Get your brain in order.
And read the question or answers.
Mine have phono connectors for push to talk jack. But most of the audio stuff now is the mini phone jack.
Yeah.
Ferrite cores. Okay, we use them to create a high inductance coil because they concentrate all of the magnetic flux around inside the core. The different material mixes determine the frequency ranges. There's a list of some of the different types. I think 31 is probably the most popular one for VHF, HF ranges, especially HF. It works, I believe, from like 1 to what's 1 up to 300 megahertz or not? There's a chart coming up. The ferrites come in toroids, beads, which Byron has a bunch of them down there on East Coax.
What's already in the bag?
Yeah.
And you can get them with the internal hole size about the same diameter as coax. Use them for common mode chokes. And then there's rods, which you used to see in the little transistor AM radios, ferrite rod with wire right as the antenna and input transformer. If you use particularly beads or toroids, you can make a high impedance common mode choke for your coax transmission line, either by slipping beads over it or winding coax around the toroid number.
And anybody that's ever dealt with King radio and Bendix King radio equipment, these aircraft, the entire company came around because of a machine to make small coils. Ed King invented it, and when he was with Collins Radio and left and took the patent.
This was a little chart I pulled that just shows some of the different mixes and different materials they use. I guess zinc is sort of the common factor in all of them. These are nickel zinc. The others are, I think that's manganese.
Manganese.
The permeability is a factor used in the inductance. The more permeability, the higher the inductance value. This column is common mode suppression. So on the type 31, you can use them as common mode chokes in the 1 to 300 megahertz range. I think it kind of falls off towards 300. It's still usable. Some of the others are much narrower. You get down into 52, 61, they're for higher frequencies. They don't do the lower frequencies. 73 is typically low frequencies. I'm not familiar with the 75J, but again, it's fairly low end of HF below. If you use them in tuned circuits, it shows the kind of operating ranges. And transformers, they act a little differently. Normally, the 31 mix is what you use for a choke. Any impression?
You want to talk about permeability?
All right, talk about permeability.
I want you to talk.
Density. I don't remember the formula for inductance where you use it. But it has to do with the number of turns, the area of the cross-section of coil, and the permeability. But I don't remember more about it.
And more permeability, less for
Yeah, permeability is a multiplier of those other factors, the turns and the diameter basically of the coil, because more area is more inductance. You would think maybe a smaller one would, but larger diameters give you more inductance because you got more of a magnetic field, you got more wire. That's all I know about it. And
it doesn't have anything to do with how much water is coming in.
And you don't need to know it for the test. I don't even remember it coming up on the extra. So what's the advantage of using ferrite core toroidal inductors?
all the above.
Yeah. That's the other. Sounds good. All the above. Large inductance. You can get them. There's lots of different mixes, I think, besides the ones I I showed. So you can pick the mix for whatever you're trying to do. And they contain the magnetic field pretty much. So how does a ferrite bead or core reduce common mode RF current on the shield coaxial cable?
Greg, and it's
It's like putting an inductor in series, essentially was what you're doing. You got common mode is current coming down the outside of the shield. So if you put a bead around it or you wind it around the toroidal core, in effect, you're making an inductor on the outside of that shield. So it blocks, it opposes the current flow. What determines the performance of a ferrite core at different frequencies?
see,
You read ahead. The next. Okay, so we learned that analog integrated circuits. One example is an operational amplifier. Transistor digital logic has high power consumption compared to CMOS. Conversely, CMOS is low power consumption compared to TTL. Microwave ICs are called monolithic microwave integrated circuits. And display devices can be a lot of things, but in this case, it's LEDs that emit light when they're forward biased. Connectors, BNCs have a 4 gigahertz upper limit. N connectors are moisture resistant and useful to 10 gigahertz. SMAs are small threaded, useful to 12. In their question, they just said several. And RCA phono connectors are used for audio and DC. Ferrite core toroids, the mixes determine the frequency and impedance characteristics. It can get large values of inductance, contain a magnetic field in the core, and you can use them for common mode chokes on coax. We have a break. That's all for today.